Welcome to geometry video for skill number 83. I can find the measure of angles formed by two lines intersecting a circle. In the previous skill we learned that if we take a vertex and place that vertex on the edge of a circle, the measure of the angle is half of the arc. And this would occur in a condition where the angle is located on the circle and both lines are secants to the circle, or even if you had the circle and one line was tangent and the second line was secant. So if we had a 100-degree arc, then we would know that the angle is half of that and that the angle is 50 degrees. In this skill we're going to look at other examples of how angles exist within circles. So first we have a vertex inside the circle. So instead of our vertex being on the perimeter of the circle or the circumference, we have the vertex of the angle occurring on the inside. And what we find here in case 2 is that the measure of angle 2 is equal to 1/2 of arc AB's measure and arc CD measure combined. So if we take, for example, if we had 100 degrees here and 40 degrees here, the average, or 1/2 of 100 plus 40, is 70 degrees. So angle 2 is 70 degrees, which incidentally makes this angle 70 as well. And using linear pairs we could find out that angle to be 110. And vertical angles we can also figure this to be 110. Alright, the next example that we have is a vertex on the outside of a circle. And again, I forgot to close my parenthesis. The vertex on the outside of the circle is going to be half of the difference. So we take arc CD, subtract arc AB, and then multiply it by 1/2. So in this case, if this was 100 degrees and this was 20 degrees, we'll find that the measure of angle 3 is 1/2 of 100 minus 20, which is 40 degrees. So angle 3 is 40 degrees. And basically these are the three conditions that we have, and we should be able to apply these in several contexts. In this example I have a diagram with two secant lines and one tangent line. That tangent line creates an arc with secant dB, and that arc is measured 150 degrees. And our goal is to find the measure of arc ABE. Well, we know this is 150 degrees, but we need to find out that arc. And what we find is a condition where we have an angle with the vertex on the circle. So arc ABE should be twice of that angle. So twice of 100 degrees is 200 degrees. So we now know that ABE is 200 degrees. The second part of the question asks us to find the measure of AB. Well, if BE is 150 and ABE is 200, then we know that the remaining piece is 50 degrees. The next thing they ask us to find is the measure of angle DCE, and DCE has the vertex inside the circle, so the measure of that angle should be 1/2 of the two arcs. So we take 1/2 of 50 plus 70, and 1/2 of 50 plus 70 is 60 degrees. So we find that in our diagram DCE, DCE is 60 degrees. So 60 degrees right there. Which means also this is 60 degrees because of vertical angles. And the question continues. It asks us to find the measure of ACD. Well, if ACD is this angle, and we know this angle to be 60 degrees, they form a linear pair, so 60 plus ACD is 180. And we find that ACD is 120 degrees. And the final question that we ask is the measure of AD. And there's a number of ways we can do this now that we've found all the information. 150 plus 170, 70 plus 150 plus 50 is almost all the circle, and we're left with that piece. So we can take 360 and subtract those three pieces. Or we could use what we've learned about angles and their relationship with circles. Alright, this concludes the lesson, and the key ideas and concepts that we want to consider is if you have an angle that is inscribed in a circle and it's on the circle, then you're going to get that the measure of the angle is half of the measure of the arc. So if you have a 20-degree arc, then your angle is going to be 10 degrees. We have a second condition where the vertex is located inside the circle, and we take the average of the two outside pieces. So if this is 100 degrees and this is 110 degrees, then the measure of the angle is going to be the average of those two, which is 105 degrees. And finally, the last condition is when the vertex is on the outside of the circle. And in this case, you have to take the difference. So 40 degrees minus 20 degrees, and you cut that in half, and that gives you 10 degrees.